Hey, what's up everybody? Today we're going to be covering FHRPs, or First Hop Redundancy Protocols. These are used primarily as a way to make sure that if one router goes down, another takes its place and connectivity is not interrupted all that much. These can be useful for the aforementioned redundancy, but can also be used for load balancing. The one I'm going to cover here is going to be Hot Standby Routing Protocol, a Cisco proprietary one. However, there is a more open version called VRRP, Virtual Redundant Routing Protocol. God, that one's hard to say. However, they're both more or less the same. So we'll go with HSRP because it's in Packet Tracer, and I don't really have a way of setting that up with the current lab that I have. Looking into that, but for now, Packet Tracer will do. So let's go ahead and come on in and have a look at our topology here. So we have 3 VLANs pre-configured. Over here we have our virtual IP address. This is the main way that FHRPs work. There's an IP address that all of these devices will share at the same time. And we're going to set up a hierarchy so when devices try to reach out and go online and reach out to another network, these routers will know which router should be doing the work and which one should be waiting. So let's go ahead and set this up real quick. Let's go into R1. I'm going to go ahead and just copy these commands real quick because I kind of want to get them in real fast because Packet Tracer is kind of buggy. But we'll talk about them. We'll talk about the commands right now. All right, so with HSRP and VRRP, you set it up per interface. So in this case, we are using the classic router on a stick topology. So all these VLANs are trunking to R1 over G101 from switch 0 to G01 on R1. All right, so we're in that interface. Do right, because I've got a demonstration to do in just a mo. Then we want to select our version. Just to be sure, run standby version 2 if you're using HSRP. And then from there, we're going to set up a standby group. So the way this reads is we're going standby group 25. In this case, I'm having my group number match my VLAN. And then the IP address for this group is going to be 10.25.03. So anything with a gateway address of 10.25.03 or otherwise trying to reach this group, 10.25.03, this is the IP address they want to hit. All right. Then in standby group 25, we want this router to be the active router. So 200 is a good way to make sure of that. The default is 100. The higher priority wins in this case. And then we've got standby group preempt. So what happens here is when R1 goes down, R2 takes over. Then when R1 comes back, R1 is going to say to R2, give me back my active state, and R2 will relinquish it. All right, so let's go ahead and configure R2 to do the same thing. And copy, paste, do right. All right, so same basic principle here. Standby version 2, the versions need to match, so that's why you want to explicitly state the version. Don't ever assume the version that you're dealing with. Standby group 25, 10.25.03, so that means this router is going to be listening with 10.25.03 for this group, in this case this VLAN, And then we're cranking the priority down to 50 from 100. All right, cool. And now this router is in standby mode, waiting for R1 to go down. And I did do right. All right, cool. So let's have a look, see what that looks like here. So what I'm going to do is I'm going to ping the ISP's loopback interface of 50.50.50.50. And let's see what happens. We'll advance. All right, so see what happens here. Okay, so they chose a really bad color, but that's okay. So what happened here when these broadcasts went to both, because both of them have this IP address, R2 is saying, I'm not touching this, I am standby. R1, however, will happily take it and send it to the ISP. And then it will come back the way it came. Success. Very nice. All right, so life is going good. La-di-da-di-da-di-da. And then some idiot is not paying attention to what they're doing and accidentally cuts R1 off. All right, so R1 is down. R2 is now going to notice, oh, hey, R1 is down. So all of a sudden, it is going to switch to active from standby. I'm going to fast forward quite a bit because packet tracer things, man. Nope, it's not done yet. I hate packet tracer sometimes. Good enough. All right, so let's go ahead and see what happens when we send a ping again. Simulation, ping, boom, boom. Now R2 is going to accept it. ISP takes it, sends it back. Boom. Very nice. Connectivity issue resolved. In reality, you would only be down for a few seconds. So not that bad. Not that bad at all. All right, so the emergency is over. R1 is coming back up. And we're going to see it come back up. And as you can see, it's resuming its duties. It's actually, we're probably going to see an issue with OSPF neighborship, but that's fine. I'm going to go ahead and exit clear IP OSPF process. Yes. Just to be safe. All right, so we're good. So now, with R1 back, we're going to go ahead and ping one more time. And what happens? R2 is again rejecting the traffic, but it's going to come back to R2 because packet tracer things. But then the rest of the traffic should come back. Just packet tracer things, ignore that. All right, reset sim. So there you go. Setting up HSRP is not that bad. And VRRP is going to be very, very similar. Going forward, I am going to be working in hardware with the home lab that I have set up. We'll be setting up a link aggregation group. We'll be setting up VRRP. We'll be doing a few other things as well. Anyway, I hope this is helpful and have a good one.